Okay, let's jump right into this deep dive. We're cracking open your sources today.
Yeah, ready to go.
We're exploring the world of financial calculations, like specifically focusing on how money behaves over time with regular payments.
Right, whether you're saving or borrowing.
You've given us a really useful stack of notes, lots of examples here, covering everything from, basic savings plans to the details on loans, mortgages especially.
Lots of numbers to work with.
It's packed with the kind of stuff we need to really see how this works.
Definitely.
So our mission, well, it's pretty clear. Take these calculations, these scenarios, and kind of strip away the confusion.
Get to the core insight.
Exactly. Pull out the most important nuggets. The goal is for you, listening, to walk away understanding what truly matters with these financial tools.
Yeah, using the actual details from the sources.
Perfect.
And it's about much more than just the math, I think. Understanding these concepts really shows the long-term impact of your financial decisions. It reveals where your money's going, how it's growing, or, how the cost of borrowing adds up.
Okay, perfect. Let's start with the absolute foundation from your sources, the idea of an annuity.
Okay.
The definition is simple, but it's key. It's a series of equal payments. Could be deposits, could be withdrawals.
Right, equal amounts.
Made at regular, fixed intervals over a specified period of time.
Consistency is the name of the game there.
Think about your own life. You probably encounter these constantly. Your mortgage payment, maybe a car loan payment.
Those regular deposits into savings, insurance investments maybe.
They all fit this pattern. And your notes highlight two main flavors, right?
The ordinary annuity and the annuity due.
Ordinary annuity, payments at the end of each period, like a typical loan payment.
End of the month usually.
And the annuity due payments at the beginning of the period, like rent or maybe a lease payment.
Exactly. And the critical part is that regular intervals and equal payments.
Yeah.
That structure matters.
Why is that?
Because that consistency is what lets us use these formulas, these calculators, to predict the future value or figure out today's value. It brings predictability.
Right, predictability. That makes sense. And just to get a feel for the scale of these intervals over time, your sources had a quick warm-up.
Yeah, just some quick math.
Like how many months are in, say, 40 years? It's 480?
That's a lot of payments.
Yeah.
Or compounding periods.
Or weeks in 17 years.
Yeah.
884. It really puts into perspective how many times those payments add up or compound.
It does, especially over decades.
Okay, with that base, let's jump into the first big application. Finding the future value of an annuity.
Okay, saving up.
This is your classic saving up scenario. You make regular deposits, and you want to know how big that pile of money will be later, including the interest.
How much it grows to.
Your example 1 gives us Tom and his mutual fund. He puts $50 into a fund at the end of each month, just for 6 months.
Short-term example.
And the fund pays 6% interest, compounded monthly.
And what's neat is how the time works. That first $50, it earns interest for 5 more months.
Ah, right, because it goes in at the end of month 1.
Exactly. The next one for 4 months, and so on. The very last $50 deposit. It doesn't earn any interest in that first period.
Makes sense. And the calculation in your source shows after those 6 months, Tom has $303.77.
So he put in $300, $50 by 6, right?
Yeah.
And he earned $3.77 in interest. It seems small, but it shows that even tiny, consistent savings start earning immediately.
It's start. Then we see the real power over a longer time with example 3, Moira's trust fund.
Okay, longer horizon here.
Her parents invest $800 every 6 months from when she's just 6 months old until she turns 16.
So 15 and a half years, 31 payments.
Into an account earning 7% compounded semi-annually, and the result,
Big number, I bet.
on her 16th birthday, that fund has grown to $43,543.58.
Wow. And they only put in, what, 800 times 31? That's $24,800?
Right, so over $18,000 is just from interest earned. That really shows the impact of consistent saving over many years.
Time is your friend there, definitely.
Okay, one more in the savings area. Example 4, Samuel's trip savings.
Okay.
Samuel needs $3,000 in 3 years. He decides to deposit $200 every 3 months. Quarterly deposits.
Into an account paying 6% compounded quarterly. Seems reasonable.
So the big question is, will this plan get him to his $3,000 goal in 3 years?
Let's see. Your source gives the answer. After 3 years, Samuel's account will only have $2,608.24.
Oh, wow. Not quite there.
No.
And this is such a key takeaway, isn't it? Just making regular payments isn't automatically enough.
Right. You have to check the math.
Samuel's example shows you have to actually calculate if your payment, the interest rate, and the time you have are really going to get you to your goal.
The numbers have to work. You can't just guess.
Okay, let's flip the script then. We looked at saving up to a future amount.
Right. Now let's look at the other side, present value.
What if you know you need a stream of payments in the future, and you want to know the single lump sum needed today to make that happen?
That's present value of an ordinary annuity. How much do I need now?
It's the amount you need right now, today, at a certain interest rate, which will then be enough to provide all those regular future payments.
It's like the today value of that future income stream.
Your example 1 here is John's college fund. His parents want to pay him $5,000 at the end of each year for 4 years, starting next year.
Okay, 4 payments of $5,000.
Their account earns 5.5% compounded annually. According to your source, the amount they need to invest today is $17,525.75.
Think about that. John gets $20,000 total. 5K by 4.
Yeah.
But they only needed about $17,500 today. The difference, almost $2,500, is the interest earned over those 4 years.
So that initial lump sum grows just enough to cover the payouts.
Exactly. The interest fills the gap.
Then there's Sarah and her lottery winnings in example 2. She won $500,000.
Wow.
Nice problem to have. She wants to invest some of it today to get $2,500 a month for the next 20 years.
That's 240 payments. A long time.
The investment earns 6% compounded monthly. Your source calculates she needs to invest $348,951.93 today.
That's a big chunk of the $500,000. Shows how much you need upfront to secure a long, steady income stream like that.
It really does. Okay, example 3 is more relatable. Chris buying a TV on a payment plan.
The store financing offer.
He's offered $250 payments every 3 months for 2 years, 8 payments. Interest is 9% compounded quarterly.
Okay.
The crucial insight your source reveals is the actual cost of that TV, if paid today, is the present value of those payments.
Which is?
$811.80.
Right. So he pays $2,000 total.
Sure.
8 by $250. But the TV's value today is only $1,811.80.
Meaning he pays about $188 extra just for financing it?
That's the cost of financing right there.
Typical.
Those easy payment plans often hide that interest cost. Understanding present value exposes it.
Very useful. Okay, so sometimes we know the goal, future, or present value, but we need to figure out the payment itself.
Right, solving for the PMT part of the equation. How much do I need to save each month? Or how much will my loan payment be?
Exactly. Let's revisit Nathan's trip goal. He needs $3,000 in 3 years. Account pays 6% compounded monthly. What's his required monthly deposit?
The calculation flips around.
And your source shows he needs to deposit $76.27 every month.
So not a huge amount, but consistent. That's what gets him there.
Or Nina, who won $100,000 and wants it paid out quarterly over 5 years. Money earns 5% compounded quarterly.
She wants 20 equal payments.
Your source calculates each quarterly payment will be $5,682.04.
Okay, so these calculations let you figure out the exact regular commitment needed.
Yeah, the payment you need to make or will receive to hit a specific goal.
Super practical.
Now, let's shift gears a bit. This is really important. How changing the conditions of a loan affects everything.
Oh yeah, the interest rate, the term, how often you pay. Huge impact.
Your sources use James's $19,000 car loan as a great case study.
Okay, let's look at that.
First up, the interest rate. Keep the loan at 3 years, 36 months, monthly payments. Compare rates.
Right.
At 6.5%, the monthly payment is $582.33. Total interest paid over the 3 years, $1,963.92.
Okay, baseline.
Now, bump the rate to 8.0%. The monthly payment goes up to $595.39. Not a massive jump per month, maybe?
Seems manageable, maybe $13 more a month, but the total interest
jumps to $2,434.07.
Wow. That's almost $500 more interest just from that 1.5% rate increase.
Exactly. It shows how even a small rate difference adds up significantly over the loan's life.
Definitely pays to shop around for rates.
Next, the effect of the loan length or term. Keep the rate at 6.5% monthly payments. Compare 3 years versus 5 years.
Okay, same rate, different time frames.
We know the 3-year term, $583.33 a month, about $1,964 total interest. Now, stretch it to 5 years, 60 months.
Monthly payment should drop.
It does. Drops to $371.76. That looks much more affordable monthly, right?
Yeah, that's the appeal. Lower payment makes it seem easier to handle.
EUT, the trade-off.
Yeah.
Your source reveals the total interest paid on the 5-year loan, $3,305.41.
Ouch. So you save about $210 a month on the payment.
But you end up paying almost $1,400 more in total interest over the 5 years compared to the 3.
That's the classic longer-term trap. Lower monthly cost, much higher total cost. Big trade-off.
Definitely. Okay, how about payment frequency? Same $19,000 loans, 6.5%, 3 years. What if you pay more often than monthly?
Monthly, semi-monthly, bi-weekly, weekly?
Monthly, $583.33 payment, $1,963.92 interest. A semi-monthly, $290.81 each. Total interest drops a bit to $1,938.30.
Right, a small saving.
Bi-weekly, $268.41 each. Interest is $1,934.30 each. Interest is $1,924.50.
So paying more often does save a little interest, even with the same annual amount paid. Why is that?
Because you're chipping away at principal slightly sooner within each month. Less principal means slightly less interest accrues.
Makes sense. Small effect on a car loan maybe, but could be bigger elsewhere.
Your sources also use Nadine's $1,200 loan at 9.5% to show how your desired payment affects the timeline.
Okay, flipping it around again.
If Nadine can only afford $50 a month, your source says it takes her 22 months to pay off that $1,200.
Almost 2 years.
Compare that to aiming for a 1-year payoff, $105.22 month, or a 2-year payoff, $55.10 month.
So her choice of payment directly impacts how long she's in debt and the total interest. What does she prioritize? Lower payment, faster payoff, lower total cost.
Exactly. Those are the trade-offs she has to weigh.
Okay, let's talk mortgages, the big one for most people.
Yeah, the loan secured by property. Your sources give a good rundown of terms.
Right. Fixed rate means the rate's locked in. Amortization is just paying it off gradually.
Amortization period is the full calculated time to repay, like 25 years. That sets your payment.
But the mortgage term is just the length of your current contract, often shorter, like 5 years in Canada. Then you renew.
Got it. Amortization table shows the principal interest split per payment. And appreciation rate is property value growth.
And a key technical point for Canada. Mortgage interest is always compounded semi-annually by law.
Right, even with monthly payments. So calculator settings need PY12, CY2.
Crucial for accuracy.
Okay, let's look at Victor's condo mortgage. $196,500 price, 25% down.
Okay, so down payment is $49,125.
Meaning the mortgage amount is $147,375. The rate is 7.5%, 5-year term, but amortized over 25 years.
So the monthly payment is based on that full 25 years or 300 months.
And your source shows that payment is $79.13 per month.
Okay.
Now the example focuses on just that 5-year term. He makes 60 payments, 60 times $178.13. $65,311.20 paid in total during the term.
And here's where amortization really hits home. How much of that actually went to principal?
Your source reveals within those first 5 years, only $12,184 went to paying down the $147K loan balance.
Wow. Out of over $65,000 paid, only about $12,000 reduced the debt.
The rest, over $53,000, was pure interest. It dramatically shows how front-loaded the interest is on long loans.
You pay very little principal early on. That's why the balance seems to barely move sometimes.
The source also notes if the condo appreciates at 5% per year, it'd be worth about $250,789 after 5 years.
So the asset value can grow while the debt reduction is slow, which is, part of the investment picture.
Okay, let's really hammer home the mortgage conditions. First, the amortization period. Section 6.5 uses a $125,000 mortgage at 9.25%.
Okay, comparing different payoff timelines.
A 15-year amortization. Monthly payment is $1,273.54. Stretch it to 25 years. Monthly payment drops to $1,055.56.
That's over $200 cheaper per month. Makes the 25-year option seem way more affordable.
It does. But here's the kicker. The total interest paid.
Let's hear it.
Over 15 years, total interest is $104,237.20. Over 25 years, total interest is $191,668.
Whoa, that's almost $87,000 more in interest just by adding 10 years to the amortization.
That perfectly illustrates the trade-off. Lower monthly payments come at a massive long-term interest cost. Huge decision point.
Okay, now payment frequency for mortgages. Section 6.6, Bonita's example, starts with a $1,460.07 monthly payment.
Comparing how often you pay.
If you pay monthly, semi-monthly, regular bi-weekly, or regular weekly, your total paid per year is basically the same. Around $17,520. All right, just 12 monthly payments spread out differently.
But then they introduced the accelerated options, accelerated biweekly and accelerated weekly payments.
What happens there?
You end up paying $18,981.04 in 1 year. That's significantly more.
How does accelerated work? Why more?
It's simple. Accelerated biweekly takes your monthly payment, divides by 2, and you pay that every 2 weeks.
Okay, half the monthly payment every 2 weeks.
Since there are 26 two-week periods, you make 26 half payments. That equals 13 full monthly payments per year.
Ah, so you sneak in one extra monthly payment each year?
Exactly. Same logic for accelerated weekly. Pay 1/4 of the monthly payment each week, 52 times a year, equals 13 full monthly payments.
And that extra payment goes straight to principal.
Yep. Which is why your sources confirm the accelerated frequencies pay down the mortgage much faster.
Makes sense. You're attacking the principal more aggressively.
The final example nails this. $139,000 mortgage, 8.75%, 25-year amortization, monthly versus weekly.
Okay, quantify the difference.
Monthly payment, $11,128.14. Total interest over 25 years, $199,442.
Now switch to weekly. The payment would be about $260.34, $1,128.14 by 1252.
Right, and the outcome. Paying weekly shortens the loan term from 25 years down to about 23.6 years.
Shaves off almost a year and a half. And the interest saved.
Total interest with weekly payments is $180,587.14. That's a saving of $18,854.86 compared to paying monthly.
Almost $19,000 saved just by paying weekly instead of monthly and getting out of debt sooner.
It's powerful stuff.
That really sums it up. Less interest paid, less time needed, just by increasing payment frequency. Simple change, big impact.
Wow. We've really covered a lot from, simple regular deposits growing over time to these complex mortgage structures.
Yeah, it's amazing how that core idea of regular payments underpins so much.
Saving or borrowing, it's fundamental.
And the key takeaway, the so what, from all this, I think, is that understanding how interest works, seeing the real impact of these variables, payment size, frequency, term, amortization, it's not just academic.
No, it's practical knowledge.
It gives you powerful knowledge to make genuinely informed decisions, building wealth, managing debt. It all connects.
Absolutely. Whether you're saving for a trip, funding college, buying a car, or that huge step of buying a home, these calculations are right at the heart of it.
They really shape your financial path.
So based on all these examples, especially those mortgage ones, here's a final thought for you listening. Consider how small, seemingly insignificant changes.
Like adding just a little extra to a payment.
Or increasing how often you pay, like weekly instead of monthly.
Or choosing a slightly shorter loan term if you can manage it.
How could those small adjustments potentially translate into thousands, maybe even tens of thousands of dollars in savings or extra earnings for you over the long run?
What small change could you explore making?
Definitely something to think about. Thanks for joining us for this deep dive.